Good afternoon, ladies and gentlemen. Welcome to join me at the stage of FIRA, the International Forum of Agricultural Robotics. This is Zhenzhong Su. I'm the CEO, co-founder of Fixposition, and today I'm very glad to have the opportunity presenting our new product, Vision RTK, precise positioning sensor with increased reliability and availability for the agricultural robotics. So that's how the presentation scheduled for today. I will start with a short introduction about the company and talk about the precise positioning and its challenge in agricultural application. And then we will present you Vision RTK as the solution for that challenge. Also, we're going to show you the performance in real world testing. And then I will end today's presentation with a conclusion. A little bit about myself. So I did PhD at the ETH Zurich exactly on high precision RTK GNSS positioning. And that's also where I learned what RTK can do and what the limitation is. So now, today we are purchasing a dream to making RTK more available through my company Fixposition. So Fixposition was founded back in August 2017 with the two ETH Pioneer Fellowship teams from ETH. We have a combined 10 plus years in both GNSS positioning and computer vision technology. So after company foundation, we were immediately incubated by European Space Agency into their business incubation center in Switzerland. In December 2019, we successfully closed our seed round led by top Silicon Valley VC True Ventures. And in the same round, we welcomed our core investor as a chairman to join the company who bring 20 plus years experience and already built up a company from scratch to IPO as an industrial leader in GNSS sector. Along the 3 years journey, we already received a lot of recognition. We have already launched 4 products into the market, and we have worked with many great customers and partners. Today, I would like to highlight 3 of them. So first, it's a RoboSense, the Zhenzhong light show company. We have sold hundreds of centimeter accurate RTK sensor to them. Now, these sensors are on board of their drone doing beautiful light shows in the sky with the precision and reliability. The other 2 are from the autonomous robot sector. So first, Neolex is the #1 delivery robot player in China. We have done successful pilot and product demo together in Switzerland. And now we are working closely to integrate our Vision RTK into their platform and get ready for the next big movement. Pixmoving, another innovative player from the autonomous robot sector, they're focusing on providing autonomous chassis for various applications, and Fixposition are super happy to support them to grow their business. As you see, we already gained quite some big experience and know the business well in the logistic autonomous robot sector. And today we are at the FIRA to learn also from you on how we can help also for the agricultural robot. Now I would like to share our vision and mission. So we want to guide autonomous things because we believe in the bright future of autonomous things. It's a matter of time that the robot drones will move and operate by itself so that we human beings can focus on more interesting and important matters. A Fixposition would like to contribute to that bright future by providing the best position and navigation solution. With that long vision in mind, today we're focusing on a mission of simplifying autonomous navigation by increasing reliability and expanding availability of precise positioning. Why this mission is important, you might ask. So we can dive in a bit deeper in the coming slide. So high precision position is already well established in agricultural domain. Many robots which does autonomous navigation or semi-autonomous navigation, it's already equipped with centimeter level accurate RTK sensor. So it works most of the time very well in open field where the GNSS signal are well received. But the problem always pop up whenever your machinery or your robot are enter GNSS challenging area, like inside a barn or in greenhouse where GNSS signal are totally blocked, so you cannot count on GNSS positioning at all. Or if you are driving along a forest canopy or next to a high silos, where the signal are reflected, generate so-called multipass. So the RTK accuracy will downgrade to meters or even tens of meters. Your navigation autonomy can simply not rely on this positioning anymore. This is what we learned from our customer, and we believe that that is the same challenge for the agricultural sector as well. So that's why we are very proud and very happy to present you our solution to this challenge, which is the Vision RTK product. We managed to integrate a lot of technology into this such a small matchbox size box. As you can see in the picture, as well as the sensor in my hand, we have two GNSS RTK receivers inside. These are the two GNSS antennas. We have a camera, which enables computer vision. And we have also IMU sensors, including accelerometer, barometer, gyros, and many others. So we can provide you the sensor as a plug and play modular, as well as an OEM board to customize for your design. The beauty of the product and the sensor are not relying on the hardware only. It's more relying on the software that are running on board of the sensor. That is our sensor fusion engine. The sensor fusion engine takes raw data from IMU, from GNSS, from camera image raw data, and feed it into a global optimization-based estimation. We take the advantage of the fact that the error source of IMU, GNSS, and computer vision are totally independent from each other. For example, in a tree surrounded area where GNSS signals are totally reflected or blocked, but the camera can capture nice features from the trees and surroundings to use this good image data to calibrate the wrong GNSS data. And in other scenarios, the other way around. So through the sensor fusion of our product, we can output high accuracy in centimeter level accuracy in almost all outdoor environment with high reliability, and even expand this high precision to also indoor transition situations. On top of that, we provide you the sensor in a very low cost with a lightweight, compact size that's suitable for all sort of platforms, from small to large size robot or drones. Now I would like to show you more about the real world performance. So we did intensive test in real farm that is close to Zurich. As you can see in the situation plan here, this farm contains both the open field, the nice GNSS environment, as well as all sort of GNSS challenging environment, including GNSS denied area when we drive into a bomb or trees that are doing the GNSS signal reflections. In this slide, we show you the performance of our sensor against some high-end device in the most challenging situation. This is a video recording of our benchmarking test in this farm. On the left side, you see the camera view from our Vision RTK sensor. The blue dot presents the feature point we use in our computer vision. On the right side, you see the tracks presented in different colors. The ground truth is generated from post-processing of the high-end RTK plus INS device. The red dot presents the RTK only solution. The yellow one presents the real-time solution from this high-end RTK plus INS device. And the blue point presents the Vision RTK solution from Fixposition. As you see, it all works well in the outdoor environment at the centimeter level until we are entering the bomb where the GNSS signal are totally blocked. Then you will soon see that the RTK only solution start to differ away from the ground truth up to even several meters wrong. So in this case, you can simply not count on this accuracy anymore for your autonomous or even semi-autonomous navigation. On the other side, you see our Vision RTK in blue are still well aligned with the ground truth, has the same good performance as the way more expensive high-end RTK plus INS device. So this is a typical good example and evidence to show you that Fixposition Vision RTK can provide centimeter level accuracy in outdoor and even maintain high accuracy for outdoor to indoor transition scenarios. Now I would like to make the conclusion of today's presentation. We will highlight 4 features and its benefit to explain why Fixposition RTK will be your solution. So the first feature will be the out-of-the-box solution we offer to you as a navigation and positioning sensor. This will, for you as an end user or OEM robot manufacturer, to avoid large investment and long in-house development for your localization technology, so that you can focus actually on your core business of building the most awesome robots. And we provide this reliable high precision solution only with the fractional of the cost compared to other high-end RTK plus INS device. The second feature will be the sensor fusion engine, which enables the high accuracy not only in outdoor, but even in GNSS challenging environment, as you already see in the previous video. And also, this means to you as an end user or a robot manufacturer, we can expand the precise positioning of your robot to a broader range of scenarios where it was not possible before with RTK only solution. The third feature will be the dual antenna, dual receiver design. This will enable instant true heading from startup and also saving the cost and hassles of IMU calibrations in each robot you will need to do. And also thanks to the redundancy of dual RTK receiver setup, you will increase the safety and also uptime of your positioning and precise operation. Last but not least is the broad range of connectivity and user-friendly web-based interface we provide to you. This means an effortless configuration, operation, and maintenance of using our sensor. And also, we support both the network RTK or the local RTK base station to facilitate your centimeter precision positioning. And last is the over-the-air software update. This is not only a convenience for you to do the software update, also it's a strong signal to you that we will continue provide more feature and also sensor performance improvement through the over-the-air software update in the long run. Now let's look at where the product is. Now, we had the product in prototype stage already back in March. After several months internal test and product performance iteration, we have done the product announcement in mid-October. And up to now, we received tremendous amount of requests and also good feedbacks from robot company already. In 2021, we will be available for volume orders. And down the road, we will provide more interface to even embrace more sensor input to our fusion engine and more features like object detection and so on as well. So we want to be your long-term partner to support your business growth. If you are already interested and want to test your sensor, the sensor by yourself, so we provide you the evaluation kit with a fully fledged plug-and-play setup, even come along with a easy-to-use web-based interface for the sensor configuration, even for real-time visualization of the sensor output on top of a map. So just contact us. We will be happy to support you. Now, I would like to thank your attention, everyone, for listening to my presentation. And I'm actually more looking forward to hear from you to see how you see the value of this new product and also how we can use this Vision RTK for agricultural robot manufacturing. So I would like now switch to my colleague Andy. He will pick up some of the questions. I'm happy to answer them in live.
So we're going to start with the questions from the Q&A. The first question is from Florian. Does the product provide 2D or 3D pose, or 2D plus heading maybe?
Yeah, that's a really good question. Actually, I can have the opportunity to tell the best of our sensor. So it provides both 3D position, 3D velocity, acceleration, as well as a 3D pose, which is almost everything that the robot navigation needed. So heading is just part of this 3D output of a roll your pitch output as well.
Good. Next question would be, how do you get the RTK correction GSM, fixed antenna, RTKX?
Yeah, so I think this is related to how we can receive the correction data. So we support both the network RTK, which means as long as you can get our sensor connect to an internet, we can receive the entry-based network RTK correction. This can be from the state-based core station, or even you can also connect your local base to Fixposition's entry cloud. Also, we can connect to local base station, which most of the traditional surveying grade RTK base already support. So,
great. Next question is, how does the Vision RTK system perform during prolonged navigation in a challenging environment for a 20 kilometers, 40-minute trip through a forest with a constant heavy canopy? So 20 kilometers, 40-minute trip, heavy canopy.
Yeah, so for this, I would say we never tested in such a long situation, but based on the test we already done and my understanding of our technology. So for a forest canopy, as long as the GNSS signal are still available, and that is the sweet spot of our sensor where we can best use the deep sensor fusion algorithm. So we can combine both the RTK, INS, and also the camera vision data to do a good global estimation. In this scenario, my assumption will be we can still keep at the centi to decimeter accuracy in the heavy canopy. But I would recommend we need to start in somewhere in the open field first to get into the centimeter, and then drive your truck or your robot entering a forest canopy, and then you can maintain for sure at the sub-meter level all the time. Yeah. With some GNSS reception still. Yeah. Sorry. Yeah. Go on.
The next question from Valeria: how many centimeters accuracy does Fixposition Vision RTK ensure?
So it depends on the scenario. In open field, it's always 1 centimeter horizontal accuracy, 1.5 vertical accuracy. We also did heavy tests in so-called forest canopy under some orchard area where the fruit trees are blocking signal. There we also always get the actual centimeter accuracy all the time. Go to indoor environment, then we will completely rely on the computer vision. Up to now, depending on the situation, we have a 1 to 3.3% of drift in proportional to the traveling distance.
Good. I want to take another question which showed up twice. That is regarding the prices. Zhenzhong, can you give a quick response to the price question for the evaluation kit?
Sure. So it's good the prices for evaluation kits. So we really encourage you first test our evaluation kits. The price is now 1,990, but we also offer this 3 weeks free trial. Only if you're happy, then keep the sensor, test it. And for the real volume production price, we can sit down together after you really enjoy and really falling in love with our product. So volume price, we can talk in separately.
Good. And now we're going to jump to some questions from the chat from Charlie. The first one is, how many miles has the system been tested over? And the second is, what cameras does it require for the visual odometry?
Exactly how many miles? So depends on different scenarios. So on low driving speed cars and delivery robots, I did not look at the exact number, but I keep a very close eye in our R&D testing. I would say already probably 50 up to 100 kilometer already tested. I would need to double check with my team. And with the agricultural situation, it's less. And so the second, to assume something like, the second question is about the camera.
I can read it again.
Yep.
What cameras does it require for the visual odometry, and how brittle is the visual odometry in high variability camera exposure scenarios?
So for this question, I would also encourage you later on come to our booth and ask our engineer for details. So the camera is indeed used for the visual odometry. At the moment, we rather use a commercial off-the-shelf camera. So the requirement for the camera quality or so on are not that high. And we do have a special algorithm to fine-tune the exposure. So for that details, I encourage you to come to our booth, and we have our engineer team there.
Another question from the chat: is the system able to dynamically swap navigation methods if RTK isn't available?
Yes, that's all done automatically. That's the core part for the sensor fusion. They're managing this fully autonomous and giving the right weighting to different sensor input.
Sorry to interrupt, but the presentation is finished. If you have any other questions, just go on Fixposition booth.
Yeah. So thank you, Emma. Yeah, I would like to invite everyone to Fixposition booth for further discussion. Thanks a lot.
Thank you. Bye-bye. Have a good day.
Bye.